Good afternoon, students. Okay, in the previous lecture, we have studied the Bode plots of the standard factors. Standard factors means yes, K system gain, then pole lying at origin, single one pole. If it is 1 by s to the power of 1. If it is s square, two poles are lying at origin. Next, pole lying zeros lying at origin means yes, it will come in numerator. If there are two zeros lying at origin, s square. This is one factor, right? This is one factor. Poles and zeros lying at origin. This is another factor. The next, simple poles 1 divided by 1 plus ts. This is simple pole, and 1 plus ts. This is simple zero, right? These are the factors that we had come across, and what is the magnitude plot and phase plot for all the standard factors we have seen. Is it fine? Okay. Next, we will solve few numericals of g. We will give, it will be given g of s into h of s. Open loop transfer function will be given. It may consist of all these factors, maybe only one factor, or it may consist of these two factors, all the factors, right? And quadratic factor was also there, right? Okay, we'll see that also. Next. Okay, please concentrate. I will go very slowly and try to understand. If any doubts are there, please unmute yourself and clarify that step immediately, because they consume a lot of time. There's to explain also and to solve numerical also initially. Later on, if you solve a number of examples later on after practice, it will be very easy for you people. Okay, sketch the Bode plot for the system having g of s into h of s is equal to 20 divided by s into 1 plus 0.1 s, right? Okay, you can observe here, this is in standard time constant form only already, 1 plus t1s, right? So it is in time constant form already. If it is not in time constant form, bring it to time constant form, g of s into h of s. So already given in time constant form only. What is standard form and time constant form? You know it, right? So it is already in time constant form. Next, we will identify the factors, and we'll, so already in the morning I told we have to draw the Bode plot. This Bode plot consists of two things. One is magnitude plot, and another one is phase plot. Some people call it as phase angle plot also, simply phase plot, right? So before drawing the magnitude plot, I have to collect some information, what all the factors are there, what is the slope contribution, all those things I have to study due to individual factors. So we'll form the table. So we call that as magnitude plot table. So first we will do the magnitude plot table, then we will go for plotting the magnitude plot, then we will go for phase plot table. Okay, first we will construct magnitude plot table and phase plot table, then we will go for drawing the magnitude plot and phase plot in the semilog sheet, right? So semilog sheet is must. Semilog sheet is must, right? If you are not having, no problem. If you are having, try to do it parallel with me, right? If you are not having, no problem. Just have a look at it later on. Once if you get the semilog sheet, later on you can do it, right? Okay, first we will construct the magnitude plot table. Yes. So we will make column first factors. How many factors? This is one factor, k equal to 20. 1 by s is another factor. 1 divided by 1 plus 0.1 s is another factor. Totally three factors are there, right? So first column factor I want. What are the factor? Right, I will write the factors here. Then next, what is the corner frequency? So 1 plus t1s. T1 is 0.1. So omega c, corner frequency for the simple pole is 1 by t. Right, 1 by 0.1, 1 by, right, 1 by 0.1 is nothing but 10 radians per second. So only this factor has corner frequency. Other two factors does not have any corner frequency, but still I have to write in the table corner frequency. What is the corner frequency contributed by this factor? So corner frequency, we will write it. Then I have three factors, k equal to 20, 1 by s, 1 divided by 1 plus point. What is the slope contribution by every factor? So what is the slope of the line or contribution of slope? That is one thing you have to write here. Then first factor will contribute this much slope, second factor will contribute this much slope. I will write everything, but cumulative slope. If I take first, that is fine. Second, I should add, right? So cumulative, I should add the previous slope also, if any, cumulative slope. So make this column. Next, Okay, next, nature of magnitude plot. We have to tell comments here how the magnitude plot will be, how this will help, these comments will help us to draw the magnitude plot. Nature of magnitude plot. Okay, first factor, serial number, first factor, k equal to 20, that is the first factor. So this does not have any corner frequency, only this factor has corner frequency, 1 plus t1s. So the slope contribution is not there because it is a straight line we are getting. So cumulative slope is also not there, any previous slope. So I have to write, so magnitude m is equal to 20 log k, 20 log k. What is that k here? 20 log k is nothing but 20 here. So we will calculate this. So 20 log 20. So we will calculate 20 log of 20. So I am getting 26.02 dB. 26.02 dB. So you can observe, if 0 dB is the reference line, then just above that 0 dB reference line, let me take this as 0 dB reference line. So don't draw it, just roughly I am telling you. In the magnitude plot, this is 0 dB reference line, but this factor k is telling that reference line has to be shifted by 26 dB up. So 26 dB it will shift up. So this is because of k equal to 20, right? 26 dB, this is 26.02 dB. Okay, due to this factor, magnitude plot is a straight line which is shifted by 26 dB up from the 0 dB reference line. Okay, I have plotted. We will go for semilog sheet later, right? Just roughly I am telling you. So this is over. So this is 26 dB, this is my reference line. Now this will be my reference line. Earlier 0 dB was the reference line, but this factor k equal to 20, it had given contribution of 26.0 dB. This is the reference line now. Reference line. Reference line. Next. Second factor. Whether I should take second factor as 1 by s or 1 divided by 1 plus 0.1 s. I can take 1 by s or 1 divided by 1 plus. I should take first poles and zeros lying at origin first. So poles and zeros lying at origin means 1 by s. Second factor is 1 by s. In the same, right, 20 I have taken, next 1 divided by s, right? So this is the pole lying at origin. Okay, since only one pole is lying at the origin, there is no corner frequency for poles and zeros lying at origin, leave it. What is the slope contribution by this pole lying at origin? Anyone can answer? S to the power of 1. No, there is only one pole lying at the origin. What is the contribution of slope? Dash dB per decade. Dash
minus 20 dB.
Yes, good. Yes, because there is only one pole, s to the power of 1. If there is two poles, minus 20 into 2. But there is only s to the power of 1. There is only one pole lying at the origin. So contribution of slope is minus 20 dB per decade. Yes, previous slope, there is no previous slope. So this if there is any previous slope, I should add this plus this minus 20. So nothing is there. So cumulative slope is minus 20 dB per decade because nothing is there earlier. Previous slope is not there. Minus 20 dB per decade. Yes, this comment is very important because for drawing the magnitude plot, it is very important. Now my reference line, earlier it was 0 dB. Now my reference line is 26 dB. This is reference line, right? Okay, observe what the comment I am writing. Just I will write first. It is a straight line. It is a straight line of slope. Straight line of slope minus 20 dB per decade. It is a straight line of slope minus 20 dB per decade, passing through, these wordings are very important, passing through, if this k is not there, 0 dB would be the reference line, because if k is 1, for example, so it is a straight line of slope minus 20 dB per decade passing through reference line. Reference line of, now reference line is 26.02 dB, reference line of 26.02 dB, right? Passing through reference line of 26 at where? At omega equal to 1. Okay, here let me take, roughly I am drawing, this is not to the scale. So omega equal to 0.1, omega equal to 1, this is 1, next 10 log of omega, this is log of omega, right? Roughly I am drawing 0.1, 1, 10, 100, it continues. So what it is telling, it is a straight line of slope minus 20 dB per decade passing through a reference line of 26 dB at omega equal to 1. Omega equal to 1 is here. So it has to come here. So what is that? Minus 20 means it should be plus 20 here. 0 dB, sorry. Here 26 dB. I should move 20 dB up. 26, 36, 46 dB will be there. 46.02. Because 20 dB should be the slope, right? So 46 minus 26, it is 20 dB, right? Because I want 20 dB per decade slope, right? So I should go 20 dB up and mark the point here. At omega equal to 1, I should mark one more point on the reference line. This is the reference line and mark it. So you join it like this from 46 to 0. So this is a straight line of slope 20 dB per decade. Minus 20 dB per decade. Minus 20, right? Because you can observe here. Here it is. What is the slope here? Read it. It is 26. Here it is 46. So 26 minus 46. So it is minus 20 dB per decade. I hope you are getting right. So rough, actually you should draw on the semi-log sheet. Okay, I will draw it later. Now I am giving rough idea. So it is a straight line of slope minus 20 dB per decade passing through a reference line of 26.0 dB at omega equal to 1. And this slope we should continue till what? Shall I stop here or it should continue till reference 26 at omega equal to 1 till next corner frequency. Means I have, okay, till I don't know. Let me leave it blank. Let me dash dash. I will fill it up later. Till what? I don't know. Okay, let me, and we'll go to the third factor. I have to write something. What is that? I will tell you. Third one. So first factor 20 is over. Second factor 1 by s is over. Next third factor is 1 divided by 1 plus 0.1 s. Third factor 1 divided by 1 plus 0.1 s. This is simple pole. So this is pole at origin. Pole at origin. This is simple pole. Okay. 1 divided by 1 plus T1s. What is T1 here? This is right. T1 I will call it as T1. What is T1? That is 0.1. That is nothing but 0.1 is nothing but 1 by 10. Is it fine? Then what is corner frequency? We have seen omega C1 equal to 1 by T. 1 by T. Here it is T1. So 1 by T or 1 by T1. Right? So 1 T substitute T1. T1 is 1 by 10 means it is 10. 10 radians per second. 10 radians per second. Okay. This is the corner frequency. What is this corner frequency? Before this corner frequency, the slope is 0. After corner frequency, this is simple pole. What is the contribution by this simple pole? Can you tell, anyone tell slope? What is the contribution by the simple pole? What is the dash dB per decade? Dash dB per decade. Simple pole.
Minus 20.
Yes, minus 20. It is same as pole at, right? Minus 20 dB per decade. Minus 20 dB per decade. Okay, fine. What I have to fill up in this cumulative slope? Right, previously I have minus 20 dB per decade, and now due to this factor simple pole I have another minus 20. So I have to add this minus 20 and minus 20, add both of this. So cumulative. So let me, so this, so add both of them, right, and write it here. So let me take red ink only. So minus 20 plus of minus 20. So it is cumulative slope is minus 40 dB per decade. Earlier there is no cumulative slope. So just if I want I can write 0 here. 0 plus this. Right, minus 20 it is minus 40 dB per decade. Okay. Next. Okay, I have left blank here. Now I came to know what is corner frequency. It is 10 radians per second. So it is a straight line of slope minus 20 dB per decade passing through reference line of 26 dB at omega equal to 1 till next corner frequency, that is omega C1. I came to know it is till omega C1 equal to 10 radians per second. You can observe here. See here, it is 20 dB per decade. Now it is at omega equal to 1. But what is corner frequency? 10 radians. 1, 10 is here. So 10 is here means mark here. So I should go till 10. So extend this line in such a way that till 10. 10 is here. So 10 is here, right? This dotted line. So you just take the scale and extend this till it intersects 10 dB, right? This is 10 radians per second. The slope should continue because it is telling it's straight line of slope minus 20 dB per decade passing through a reference line of 26 dB at omega equal to 1. Yes, it is passing through omega equal to 1 till corner frequency, right? 10 radians per second. This slope continues here till here. Next, after corner frequency, the slope has to change compulsorily, right? This is the corner frequency omega c1 equal to 10 radians per second. So before, the slope should not change. Slope is not changing. I told 0 dB means slope is not changing. Next, it has to change compulsorily because this is lower frequency area, and after 10 radians it is higher frequency. Slope has to compulsorily change. So what is that slope? Next, due to it is contributed by the third factor, it is minus 40 dB per decade. Right, this is minus 20 dB, this is also minus 20, slope is continuing, so this is also minus 20 dB. Next, I want minus 40 dB per decade, right? So I should write the comment here. It is a straight line. Due to all the factors I should consider, cumulative slope I should consider now, right? It is a straight line. Straight line means ST means straight, right? Straight line of slope. I am using this notation, straight line of slope minus 40 dB per decade, because cumulative slope is minus 40, right? Minus 40 dB per decade. Yes, we have stopped. The slope has stopped till omega c1 equal to 10. So this should start after. So it is a straight line of slope minus 40 dB per decade after omega c1 equal to 10 radians per second. It has stopped here. Earlier the straight line of slope this much has stopped here. So another slope minus 40 dB per decade should start after omega c1 equal to 10 radians per second till I don't have any other factors, fourth factor, fifth factor, till infinity. Right, I don't have any other factors. If I am having another factor means till next corner frequency I have to write, till next corner frequency omega c2 equal to dash radians per second. But since there is no other factor, so I'll write till infinity, right? This is the table. This table we call it as a magnitude plot table. If this table is ready, then I can draw the magnitude plot very easily, right? Okay, this magnitude plot is ready. Table, I will draw the magnitude plot later. Now table is ready. Next I will go for phase table. Phase plot table or simply phase table. Next, phase angle table or just phase table or phase plot table, you said that would be better. Phase plot table. Okay, magnitude plot table is ready. Next we have to plot this magnitude plot on the semi-log sheet. That we will do it, right? Next we will do the second one is phase plot table. So we will construct it. So what is this? G of s into h of s, that is given. Let me write it here. G of s into h of s is equal to 20 divided by s into 1 plus 0.1 s. Okay, next I want to replace this s by j omega so that it will be converted to frequency domain. That is equal to 20 divided by, just replace this s by j omega into 1 plus 0.1 s. S is nothing but j omega. We are replacing. Next, I want phase angle phi. So phase is equal to phi. That is angle of, take angle on both the sides. Angle of g of j omega into h of j omega. 1 minute, just I will sit comfortably. G of j omega into h of j omega. Then angle of 20. I'll separate angle of 20 plus j0 also write. You can write if you want. Then angle of j omega. If you want, you can write 0 plus j omega or simply j omega, no problem. Then angle of 1 plus 0.1 j omega. Okay, 20 plus j0. It will come on the positive real axis, right? 0 degree. So angle contributed by 20 plus j0. You can use tan inverse of imaginary part by real part. Imaginary part is 0, real part is 20. Tan inverse of 0 is 0. That is one way. Or another one, location of point. That also you can do both. Next, j omega. 0 plus j omega, simply j omega. Where it is located? It is located on imaginary axis. So it is 90 degree directly. Let me show it. 20 plus j0. Let me take, right? Sigma j omega. So 20 plus j0 means 20 will be located. It is 0 degree here, right? The next j omega. J omega means somewhere it will be located here. 1 j omega, right? So it is 90 degree from here to here if I measure 90 degree. Next 1 plus 0.1 j omega. 1 plus 0.1 j omega. Somewhere it will come here. So at that time I will use tan inverse of, right? Tan inverse of imaginary part by real part. So tan inverse of, so which is imaginary part? 0.1 omega. 0.1 omega divided by real part is 1 divided by 1. Okay, this 0 degree, I will take this 90 degree and this to numerator. So 0 degree minus 90 degree if it comes to numerator. This also I will take it to numerator. See here, I should add the angles 90 degree plus. So it is coming to numerator means minus 90 minus tan inverse of 0.1 omega by 1 means just 0.1 omega. So this is the phase I got. If any doubt still here, you can ask, or else I will proceed. Phase angle phi is what I am getting, minus 90 degree minus tan inverse of 0.1 omega. Right? Now we will go for a phase plot table. Any doubts till here? 1 minute. I will take pause. Okay, I'll continue. Okay, fine. Okay, next. See here, frequency is varied and phase I should get, right? So I'll make the table of frequency omega. And next phase phi. What is that phi? Phi is minus 90 degree. If you want to write here, you can write, or else simplify you can write. No need to write this. But I am writing here, anyhow it is small. Tan inverse of 0.1 omega. Make 2 columns. Okay. You know that scale what I will be taking, 0.1, 1, 10 and so on, right? So I'll start with 0.1, omega equal to 0.1. Next, how to choose this? You have to choose these values very wisely. 0.1. 0.1 to 1, I should have some values, right? And what is the corner frequency? It is 10 radians per second. So 0.1 to 1. So I should have some values also. So 0.1, next let me take 0.5, next 1. 0.1 to 1, I will take 1 or 2 values. 0.1, 0.5 and 1. Why I should take these values only? You can take 0.4 also, 0.3 also, no problem. Anyone, anything, right? It is not mandatory that you should take these values, at least starting value, 0.1 to 1. So here omega is 0.1 to 1. 0.1 to 1, I will take 1 or 2 values. 0.1, 0.5, 1, like that, right? Then 1 to 10, 1, 5, 10. But corner frequency is 10 radians, 1, 5, 10. Something middle I will take, or else I will get 110. That is fine, right? Next 1. Corner frequency is 10 radians per second. Next after 1, I will take 10. You can take 5 also, no problem here. If you want, you can, no problem. Let me take 5. Next, you have to compulsorily include this corner frequency 10 radians per second. You should not skip this. Means it should come in the table. So corner frequency is 10 radians per second. This is just to mark it. This is corner frequency 10, right? Just I am marking here. Then after 10, 10 to 100, 100 to 1000, right? So it continues. But till, so 10. Next what I will do, 10, 100. Then 100 to 1000. Just it continues, right? So 5 decades are there, right? 5 cycles. 0.1 to 1, 1 to 10, 10 to 100, 100 to 1000, 1000 to 10,000. Maximum it will accommodate 10,000, right? But it continues. So on till, instead of taking 1000, so on 100, then next I'll take infinity. What I will get? Infinity. It will continue, right? So these are the values. So let me, I hope these values, let me make the equation in the calculator. So I will make this equation in the calculator, minus 90 degree minus tan inverse of 0.1 omega. Then I will substitute various values of omega and I will calculate these angles. So I am making equation in the calculator, minus 90 minus 90 I have taken, minus of tan inverse of open bracket 0.1 into omega is there. I don't have omega here. Alpha A means pink color is there. A. Instead of omega, I am taking letter A. Minus 90 degree minus tan inverse of open bracket 0.1 into A. A is the letter I am taking. That is alpha symbol is there, pink color. A I am taking. Then I will press calculate button. Calculate button. What is the value of A or what is the value of omega? Instead of omega, I take an A. So here, first value is 0.1. So I will give 0.1. So I am getting it as minus 90.5. For 0.1, phi value is minus 90.57 degree. Next, for 0.5, so I will press equal to, it is asking what is the value of A, I will give 0.5. Next, I am getting it as minus 92 0.86 degree. Next I should give the value as 1. So press equal to, it is asking what is the value of A, I will give 1. So minus 95 point. So you leave some space and write, or else minus 95.71 degree. Then for 5, I am calculating for 5. So it is a minus 116. So make the equation properly, right? Minus 116.56. Then 10 minus 135 degree. For 100, so I am getting minus 174.28 degree. Next for 1000, I am getting minus 179.42. Can anyone tell what I will be getting for infinity? Can anyone tell?
Minus 1.
Minus
180.
Yes, good. Because if you are substituting in the calculator, what I will do? It is asking for omega. So I will substitute very huge value. So let me take it as 10 to the power of 10. I will give 10 to the power of 10 here. 10 to the power of 10. Instead of infinity, I am giving 10 to the power of 10. So I am getting minus 179.9999. Nothing but minus 180. Finally, it comes to minus 180 degree. Right? Okay. Now my phase angle, phase plot table is also ready. I have magnitude plot table ready and phase plot table ready. Now I require semilog sheet. I have the semilog sheet here. Right? Already solution is there. I can show you the solution and tell you, explain you, but I will not do that. So I will draw neatly. Please observe, right, what I am doing. Please carefully. Okay. One more thing, what I will do, just I will come out of this because I need some straight lines there. So I think I will come out of this. Okay. I think this is visible. This is fine because I want need straight lines to draw. So I will be taking straight lines from here. I have to draw all those things. This is sufficient, no? Is it visible clearly, this semilog sheet? Yes? Anybody?
Yes, sir.
But problem if I come here is I don't have writing, so I should go there only. No problem. Let me. Okay, no problem. If somebody is doing parallelly with me, a graph sheet, semilog sheet, please help me out. Okay, because I need these markers, color, everything. So let me. No problem. I will continue here only. Okay, first I will draw the magnitude plot. Observe here. I need magnitude plot, right? So earlier 0 dB was my reference line. So observe here, always one more thing, please keep in the mind. The initial slope of the magnitude plot gets decided by the poles and zeros lying at origin. So I'll write one statement here. The initial slope, this is very important. The initial slope of magnitude plot, the initial slope of magnitude plot gets decided by the poles are zeros lying at origin. Yes, this is very important. The initial slope of the magnitude plot gets decided by the poles or zeros lying at origin. This is very important, right? So you'll understand this. Okay. Here there is only one pole lying at the origin. So initial slope of the line should be minus 20 dB per decade. And I have shown you, roughly I have shown you. 0 dB was the reference line. This was, and due to this factor K, it has shifted. This reference line has shifted here, right? 26 dB, right? 26.02, just round it to 26, no problem. 0.02 I cannot mark it. So 26. The next I need initial slope is minus 20 dB per decade. From 26, I will move 20 dB up, 26, 36, 46. This is 46, right? And this is omega to 0.1, 110. So it is a straight line. I have written it is a straight line of slope minus 20 dB per decade passing through reference line of 26 dB at omega equal to 1. This is omega equal to 1. This is 26 dB reference line. I will mark one point here. 46. Join this two. Right? This is the initial slope given by this pole lying at origin. Always the initial slope of the magnitude plot gets decided by the poles and zeros lying at the origin, right? So I'll go there, and before that you can observe here 0 dB, 26, 46. I don't require 60 dB, 80 dB, 90 dB above 100 dB. I require till 46 dB. Let me choose the scale. 1 division equal to or 1 centimeter. So you know that from here to 1 centimeter equal to 20 dB means 20, 40, 60. 20, 40, 60 still okay, fine. So let me choose the scale. Yes, I'll choose the scale here. Let me write it here. And one more thing. Before that, here let me take it here only. No problem. It is okay. Let me take some other color. Yes, it is visible. I think 0.1 log of omega. I should take here actually, but I'm taking here. No problem. 0.1. Next one. Then 10. I hope it is visible, right? 10, 100. Just multiply 10 times 100. Next 1000. Next 10,000. This is log of omega. Log of omega. I can take here also, no problem. I can write 0.1, right? I can, no problem. Here also I can take same thing, right? So here it is 1, 10, 100. 0.1 I cannot write it here because it is coming here, right? I cannot write it. Can I write? No, it's not possible. 100, 1000, 10,000, right? This is log of omega. Next, magnitude plot I want. So let me choose the scale. Let me write it here, scale. Let me change the ink color, red. Let me make it red. Scale, 1 division. Means 1 division means here. From here to here, 1 division. From here to here, another division, right? Totally 14 divisions are there on y-axis. 1, 2, 3, right? From here to here, right? 14 divisions are there. So 1 division equal to 20 dB plus 20 dB. This is for magnitude plot. I am taking the scale for magnitude plot, right? 1 division equal to, let me write scale for magnitude plot. Magnitude plot scale, right? This is for only y-axis. For x-axis is common. The x-axis is 0.11, 10, 100, 1000, 10,000 and so on, right? So this is only y-axis scale, y scale. Magnitude plot, y scale, y-axis scale. So 1 division equal to 20 dB. So every 1 division has 5 subdivisions. 1, 2, 3, 4, 5. So one subdivision is how much? Let me write once. What is one subdivision? Can anyone tell? What is one subdivision? One division is 20 dB from here to here. If from here to here, if it is 0 dB here, is 20 dB. So one subdivision is how much? How many decibels?
10.
Once again, I will give the chance. See here, from here to here, this is, let me take, okay, let me draw it. Later on I will take one subdivision equal to dash dB. Let me write dash. I write right now. I don't know. Okay, I will ask you later. Okay, next I will choose the scale according to this. See here, maximum it will go till 46 dB. So I am choosing the scale as plus 20 dB, right? So let me take for till 60. This is 60 dB, 40 dB. I am coming in reverse. Maximum till it will. I don't want 80, 100. Else because 46 is last, means 40 to 60. I'll take 60. The next 20, 0 dB, right? So let me write it here. Actually, okay, I have the space here. If you don't have space, you can write it here. So this is magnitude plot. Magnitude M in decibels. I am taking in decibels along this axis, along this. If you don't have space, you can write the same thing that side, this side. I have space here, but it is not in graph sheet, outside graph sheet. Magnitude M in decibels. Okay, 0 dB. Next, minus 20. Whether I require this, let me check it later. But okay, let me write it, or minus 40. Let me stop. I cannot go on, keep on writing minus 60, minus 80. Let me stop here only. Based on requirement, I will take, right? Okay. Now you came to know that one division, main division is plus 20 dB. Okay. 40 to 60, 20 dB. 40 to 20, 20 dB is there. And between one division, there are totally 5 subdivisions are there. You can observe here, 40 to 60, right? If I will go to one subdivision, what is the reading? What is the reading? If I shift like this till it go to 60, what is one subdivision? Totally 5 subdivisions are there.
4 dB, sir.
4 dB because 20 divided by 5, because 5 subdivisions are there. So 20 dB divided by 5 means 5 4 are 20 means 4 decibels. One subdivision is 4 decibels. Observe here. Now I am here 40. I will go to the next subdivision. So it is here 44. 44 next 48. 48 plus 4 52. 52 plus 4 56. 56 plus 4 60. Right? I hope you got it now. Yes. How to read the scale? Okay, fine. Next, 0 dB was my reference line. Let me draw this 0 dB reference line. Dotted level, right? Dotted. 0 dB is here. So this was my reference line earlier. Always for magnitude plot, 0 dB is the reference line. I am drawing very slowly, right? If I go there, I would have taken that line directly. Here I don't have that provision. Let me, no problem. Anybody is doing parallelly with me? Similar sheet is there? Anybody is doing? If you are doing, you can unmute yourself and respond. I am doing. Okay, nobody is doing, I think. Okay, let it, no problem. Next, k equal to 20. Reference line now it shifts to 26 dB, 26.02. I will neglect this 02. Just I will take 26 dB reference line. Okay, now I should go 26 dB. From 0, I should go. If I go up, here it is 20 dB. If I go to next subdivision, it is 24. If I go to next 28, means 26 will come somewhere here. Let me mark it here. So this is 26. So let me write 26 dB. So here it is 26 dB here. I hope you are getting 24 26. I am marking here. Next, so let me draw that line here for 26 dB. It is in the middle. It should come actually in the middle like this. I hope you are getting what I am doing. This is 26 dB shift up, right? Now the reference line has been shifted because of this k factor. K is 20. Now this is my 26 dB reference line. I am trying my best to make you understand. Please make utilization of this, right? So this is my 26 dB reference line. Let me write it here. 26 dB reference line. Yes, is it fine? Next, due to this k factor I have drawn. Okay, fine. Due to this k factor it is over 20. Next, due to this pole at origin, it is a straight line of slope minus 20 dB per decade passing through reference line of 26 dB at omega equal to 1 till corner frequency omega c1 equal to 10 radians. Please have this statement in the mind. Right? So omega equal to 0.11 till passing through 26 dB reference line at omega equal to 1. Omega equal to 1 means here. It will come here. I will mark this point. I hope you are getting. Then 26. Now this is a reference line, but I want the slope of line. Initial slope should be 20 dB per decade, something like this. But 20 dB means now it is at 26. So 36, 46. So I should go to 46. So now 40 is here. 44, 46 will come here. 46. 46. 46 minus 26, it is 20 dB, right? So slope. So mark this point and this point I have marked. I will join it. So I'll join it like this. So please take the scale and I don't have scale option here. So what I will do, or else I can go there and I can do it, I think. Okay, let me try it out. Okay, let me join it by taking the line here from 46. I will, yes, you got it. Let me change the weight. I think this is fine, I think, right? Let me change the color, which should be clearly visible. What color is better? Green. Green would be better, or this would be better, I think. It's not coming. What happened? I don't know. Okay, fine. Okay, let me shift it here once again. Let me go here. Yes. You can observe here, right? Is it visible? So what was the thing? It is a straight line of slope minus 20 dB per decade passing through reference line of 26 dB at omega equal to 1. And this slope should continue till omega c1 equal to 10 radians per second. So it is a straight line of slope passing through this 26 dB. So this straight line is passing through this 26 dB reference line at omega equal to 1. And this should continue till 10 radians is here, right? So this slope should continue here till 10 radians per second. The same thing should continue. So let me uh, go there and let me expand it till 10 radians per second. Yes, I think 10 radians. Yes, till 10 radians. You can see here till 10 radians. Is it fine? 1 minute. Now I will read out. Observe here. Now I will read. It is a straight line of slope minus 20 dB per decade. So here, if I read the corresponding reading, here it is 26 dB. Here at this point it is 46. So 26 minus 46 minus. So it is a straight line of slope minus for 20 dB per decade, passing through 26 dB reference. It is passing through 26 dB reference line at omega equal to 1. This is omega equal to 1 till this slope continues till corner frequency of 10 radians per second. Read this. Here it is 10 radians per second. I hope you understood, all of you. Any doubt you can ask, or else if you understood, please say yes. So this is the straight line of slope minus 20 dB per decade. From here to here, once again it is because here it is 10, here it is 26. Once again it is minus 20 dB per decade only. This same, this slope throughout this line. Shall I proceed, or if you have not understood, you can ask. Shall I proceed or not? I am asking you people only.
Proceed, sir.
I hope you understood, right? Till here? Okay, fine. Okay, fine. Okay, I should read the corresponding where it has stopped, where this slope has stopped. What is the magnitude? I should read the corresponding magnitude. It has stopped here, somewhere here at, what is this? 0 dB. One subdivision is 4 dB. It has stopped at 4 dB here. This one till here is 4 dB. It has stopped at 4 dB. Let me write this 4, because I should come to know that it has stopped at 4 dB. Next, I will go previous. Okay, this is over. First factor is over. Second factor is over. Third factor. Next, I have written here. This comment is very important. It is a straight line of slope minus 40 dB per decade after. It is a straight line of slope minus 40 dB per decade after omega c1 equal to 10 rad. It has stopped at 10. After 10 radians per second, the slope should be minus 40 till infinity, right? So at 10 radians per second, it has stopped at 4 dB. There I have to go 40 dB down because the slope is minus 40 dB per decade till infinity. Okay, please keep this statement in mind. I will go there. See here, it has stopped at 4 dB. I should go 40 dB down, right? So for it will come 0. So if I come here, it is 0. Means 4 divisions are there, 4 dB. But I want 40 dB down, right? So 36 dB I should go down. This is 20 dB, this is 40 dB. So I should go 36 dB down. So let me take 20, 24, 28, 28 plus 4, 32, 32 plus 4, 36 it will come here. So now it has stopped here, come 36. So just observe here, this is minus 36. From plus 4 to minus 36, it is 40 dB, right? Here from 0 to 36, it is 36 plus 4, 40 dB or not, right? I was at plus 4 dB. Now I will come at minus 36. If I come to minus 36 from plus 4, it is totally 40 dB, right? 40 dB. Yes, I hope you are getting. 0 to minus 36 is 36 dB. 0 to 4, it is plus 4 dB. Add both from minus 36 to, so it is 40 dB. So corresponding to this minus 36, mark here on 10 radians per, here I am marking here. Here I have marked here at 10 radians per second. So I should come 40 dB, right? So per decade, now it is 10. 10 to 100 is 1 decade, right? So at 10 now I am here. So I should measure, now this line is minus 20 dB per decade. Fine. Next, the slope should change to minus 40 dB per decade. So now I am at 10 here. I have come 40 dB down. Now I am at 10. I will go to 100 for 1 decade. So this is 100, 1 decade. This is 100, right? So let me mark the same thing, minus 36. Now from here to here, I will join it here. like this. Now the slope will be 40 dB per decade, because what is the slope here? If I read it, minus 36. What is the slope here? If I read at this point, now it has stopped here, plus 4, right? Minus 36 minus 4, minus 40 dB per decade slope, right? So that marking went. Once again I will draw, no problem. This mark. Now this is at 100. I will mark here. Is it fine? Next, I will go there and I'll join it. And what is the slope after this 100? Till infinity means this slope from this point, just go on extending till infinity, right? So, okay, keep it. Next, I will take the line. I will straight line. Next, I will from this point. This is the point here. So till infinity means it has to go on. Just I think it's correct. Yes. Next, I will make it thick. Wait. Okay, I'll change the color. Yes, fine. I hope you are getting this. Any doubt you can ask. You can observe here. ಸ್ವಲ್ಪ ಬಿಟ್ಟು ಹೆಂಗಾಗಿದೆ. Okay, fine. Now it left. Join ಆಗಬೇಕಿದೆ. This should join. This should join here like this, right? ಇಲ್ಲಿಂದ ಬಂದು ಇಲ್ಲಿ ಇದು ಕಟ್ ಆಗಿದೆ, ಇಲ್ಲಿ minus 36 ಇಲ್ಲಿ ಸ್ಲೋಪ್ ಜಾಯಿನ್ ಆಗಿಲ್ಲ. ಇನ್ನು ಇಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ನನಗೆ. Now I think it is fine. ಆಯ್ತು ಇರ್ಲಿ. Okay, is it fine? I hope you understood. See here, next this is minus 20. Next this slope is how much? Minus 40 dB per decade. So what is that statement I have read? Observe here. It is a straight line of slope minus 40 dB per decade after omega c1 equal to 10 radians per second till infinity. So this is the straight line. It starts here. It's a straight line of slope minus 40 dB per decade after 10 radians per second. After 10 radians per 10 radians is here. Previous to that, the slope has remained the same. Slope has not changed for lower frequency region. So minus 40 dB per decade passing right after 10 radians till infinity means it should go on. You can expand like this. So magnitude plot is over. Any doubt you can ask. Any doubt is there? Magnitude plot is over. Next, phase plot. This space is for phase plot. Any doubts you can ask. At least you understood. Please unmute yourself and tell yes, understood, so that I can proceed.
Yes, sir. Understood.
Yes, sir.
Okay, fine. Magnitude plot is over. Next, we will draw the phase plot. Yes. Okay, let me write. This is Bode plot. In this Bode plot, first one we have drawn is magnitude plot. Okay, next I will go for the phase angle table. This phase angle table I will go, right? At omega equal to 0.1 minus 90.57. At omega equal to 0.5 and so on. You can observe here minus 90 to minus 180. The scale is varying like this from minus 90 to minus 180. So let me choose the scale. One division. Let me choose here only. One division or 1 centimeter. 1 centimeter equal to, let me take 30 degree. Let me take it, right? Roughly I will do minus 90. Next, if I add 90 plus 30, 120, right? 90, 100, 110, 120. Next, 150. Minus 180. ಇಷ್ಟಿರಲ್ಲ, or else will refine the scale. 15 degree ಮಾಡಿದ್ರೆ ಎಷ್ಟು divisions ಬೇಕಾಗುತ್ತೆ? 1, 2, 3. But I have sufficient space here. I can double it. From here, let me start here. 1, 2, 3, 4, 5. So many divisions are there. So let me choose the scale, refine the scale. 1 centimeter equal to 15 degree. Let me make it 15 degree. Is it fine? 15 degree. This was for 30 degree. Next, for 15 degree, we'll see the values. Minus 90, 90 plus 15. How much? 105. 110, 120, 135, 140, 140, 150, 150, 165, 180. Yes, I am getting starting value minus 90 and ending value minus. You choose the scale in such a way that both starting value and ending value should be there. So 1, 2, 3, 4, 5, 6 divisions I require. Whether I have 6 divisions, let me check it. Yes, if I start here, let me start from bottom. 1, 2, 3, 4, 5, 6. I can choose, right? Let me start from here, no problem. Or else I can start from here only. 90, right? From 90, if I go 1, 2, 3, 4, 5, 6. I require 6 divisions only, right? If I 1, 2, 3, 4, 5, 6. Yes, from minus 90. Okay, let me start here. Is it fine? Minus 90 degree. Minus 90. So what is the scale I have chosen? Let me write the scale here. This is for phase plot. Phase plot. Y-axis scale. Y scale is 1 division equal to how much? Plus 15 degree. So one subdivision equal to how much? How many degrees can you tell? One subdivision is how many degrees? Can anyone tell? One subdivision. This is one, see, minus 90. Next 15 degree means minus 105.
3 degrees.
One subdivision is how many degrees?
3 degrees.
3, because 15 divided by 5, because every division has 5 subdivisions, 1, 2, 3. So 15 divided by 5 means 3 degree. 3 degree. Okay, 15 divided by 5 because 5 subdivisions are there, right? So one subdivision equal to 3 degree. Yes, fine. Minus 90. This is minus 105. Next, this is minus 110, 105 plus 15, 110, 120, 120 degree. Next, 135 degree, minus 135 degree. Next, minus 140, 150 degree. Next, minus 150, minus 165. This last one is okay. Some zoom option has come here. So let me write it here. This one, like this, it will come minus 180. So it is here because it is not allowing permitting me to write. This is minus 180, right? So let me write it like this. Okay, fine. Minus 180. Okay, minus 180 degree. For magnitude plot, 0 dB is the reference line. For phase plot, minus 180 degree is the reference line. So let me draw it here, but I'm not drawing here. Okay, let it be. Yes, this is 1, 10, and so on. So this is point 1. At point 1, let me mark it. For point 1, it is minus 90.57. Let me mark it roughly. No problem. It will not affect much. Minus 90 degree. Point 1 minus 90. So point 1 is here. This is point 1, right? So point 1, 90 degree. I will mark one point here. Let me take some other ink color, ink. So here it is. I have marked the point. Next, point 0.5. At point 0.5 minus 93. Let me round it to minus 93 because 92.86 means minus 93. So I will take it as minus 93. Minus 93 degree. So 0.5 minus 93. So where is 0.5? 0.2, 0.3, 0.4, 0.5. This one 0.5. 0.5. I hope you are getting 0.1, 0.2, 0.3, right? Here 0.5. 5 is the right. This is 0.5. So from 0.5 I am coming down here like this. So let me, here it is minus 90. If I come to subdivision, minus 93. This one here. I hope you are getting. This is minus 93. Here it is minus 90. And one subdivision is 3 degree. So minus 93 is here. I have marked here minus 93. Next, for 1 it is minus 96. Let me take it as minus 96. Let me round it off. 1 it is minus 96. For 1, this is 1. 1 is minus 96. 90 is here. 93, 96 is here. Right? At 1 it is, this is 1. 1 at 96. Next, for 5 it is, let me round it to minus 117. right? 5 it is minus 117. Where is 5? Here it is 5, 4, 5, minus 117, 5. You should be correct, very correct. 117. What is this? 120. 120 minus 3. 117, it's correct, right? I hope you are getting right. So it is minus 20 minus 3. 117. It's correct. Next, this is at 5. 5 is over. Whether it is marked, yes, it's marked. 5 is over. Next, at 10. 10 it is minus 135. 10 it is minus 135. 10 is here. Minus 135. Minus 135 corresponding to 10. Mark it here. Oh, it is going somewhere. This mark is going. Earlier this had went. So at 5 it is 117, right? Once again I will mark it. It had gone. It is there here. But it is very small. Okay, now it is fine. Okay, let me change the ink color. I am not getting those markings. Let me change it to this color. I think this would be fine. Yes, this is fine, I think. Here, yes, I hope these markings are visible to you now. Next, at 10 it is over. Next, at 100 minus 174 I will take. Minus 174. Let me round it off. At 10 minus 174. Sorry, at 100. 100 minus 174. 100 is here. 180 is here. At 100, this is minus 180. So if I go 174 I want, so it will come here. Is it fine? Okay, at infinity it is okay. I'll not take 1000. Let me leave this 1000. Let me not take it. At infinity is minus 180. So I'll draw the smooth curve joining all these things. Let me take uh, color. Let me change the ink color for phase plot. Which color shall I use? Same color only. Let me use, no problem. This only for phase plot what I have. So draw the smooth curve. Don't use scale. It should be smooth curve. Slowly it should drop. Now I cannot draw very much properly because pen and paper would be fine for me. Slowly, it should gradually you draw it. One more point is here. Slowly you should take. And it will reach minus 180 at infinity. You can show it like this. I hope you are getting magnitude plot. Any doubts? If you understood, say please yes.
Yes, sir.
Yes.
Yes, sir.
Thank you. Okay, magnitude plot, blue color line. Don't worry about this red color, right? Blue color line. This is magnitude plot, and another blue color plot below is phase plot. So this is phase plot. This first one is magnitude plot is over. Second one here below I have drawn phase plot. So this entire thing we call it as Bode plot. So above one is magnitude. So here I have to write the scale. I forgot something. I should write here phi phase phi in degrees. So this you have to show like this, phi in degrees, and this is log of omega. Here I have shown log of omega. Here I have shown log of omega. Is it fine? Okay, now you came to know how to draw the Bode plot. Then after drawing the Bode plot, what next? I have to judge the stability of the system. That we will see next. I hope this is sufficient for today, I think. What's the time now? 12 to 1. Already 1 hour. Okay, if I take another 1 hour, it will go. Another problem. Okay, this problem I hope you understood. Any doubt in constructing magnitude plot table, you can ask. Any doubt, you can ask. I will show you. The solution is here. This is what I have drawn. Please, you draw it on semi-log paper and practice it. The same problem. Once again, you practice it today, right? You take the semi-log sheet. If you are not having semi-log sheet, do one thing. If you have printer at home, search for semi-log sheet and take the printout of that, right? If stores are not available, means it is closed. Search for semi-log sheet, or else whatever the semi-log sheet I have sent for you people. If you want, I will send you once again. If you want, then take the printout of that and use it as a semi-log sheet. Okay. This okay, the same problem here. You can see this only I have made the table here, but I have drawn it for you people here. This I have done here, right? This I have done. So the same thing I have shown here. This is magnitude plot table, then this is phase angle table, then this is the Bode plot. I hope, right? If I keep on explaining the things like that, I hope you will not understand, right? So I have drawn. I have taken the semi-log sheet and explained it. Next, let me stop it here. I'll stop here. Request.